Hello, this is the course of data structure and algorithms. I'm going to review the hash tables, especially the part collision handling, because maybe you don't have the idea about the examples, because at the previous video, we just handle the examples without animation. So I'm creating the animations to make you understand about the concept of the collision handling. So there are three, okay, if you still remember, the separate chaining, and then linear probing, and the other is double hashing. So let's see one by one. So the separate chaining, what is separate chaining actually? So let's suppose I have those numbers, okay, 54, 18, 28, 36, 25, 41, 38, 10, 12, 90. And then I have the space here, there are 13, okay. So 13 means the n, okay. So n is the number of space that you want to prepare for a hash table. So we will do the mod n. Mod is the modulo. For every number will be processed with the mod n. So we will do the 54 mod 13, and the result will be the index that we want to store the number 54. So for the separate chaining, okay, for the separate chaining will be like this one. 54 mod 13, then it is 2. So we will put the number 54 in the index 2. And then what happened next? 18 mod 13 is 5. So we will put on the index 5. What about 28? So 28 mod 13 is 2. So we will put on the index 2. So in the separate chaining, so we will have a new chain. Okay, we call this one a new chain, or it is the separate chain. Okay, so that's why the method is separate chaining. What about 36? Okay, 36 mod 13 is 10. So we put 36 in the position index 10. What about 25? 25 mod 13 is 12. So we put in the index 12. 41 mod 13 is 2. So we have a separate chaining in the index 2. And then 38 divided by 38 mod 13 is 12. So we put in the index 12. And 10 mod 13 is 10. So we put in index 10. 12 mod 13 is 12. So we put on the index 12. And 90 mod 13 is 12. So we have the chain like this one. And yeah, the idea is, yeah, we have the chain in the index 2, we have the chain in index 5, we have the chain in index 10, and we have the chain in index 12. Okay, so this is the separate chaining method. So for every location or on every index, we have a new map. Okay, so what about the linear probing? Yeah, so the same idea, we have the method which is mod n. So let's suppose we have this number, okay, 18, 41, 22, 44, 59, 32, 31, and 73. Right? So this is the same example that we already saw on the PBD. So what will be the process to put those numbers into the hash table? So we will check one by one. 18 mod 13, so it is 5. So we can just put the number 18 into the location index 5. 41 mod 13 is 2. So we have the number 41 in the index 2. 22 mod 13 is 9. Then we just put into the index 9. 44 mod 13 is 5. Oh, 5 already has one value, which is 18. So we need to figure out, like I mentioned before, the linear. The linearity means I want to change the 44 into one position, which is 6. So 59, because 59 mod 13 is 7, then yeah, there is no issue because 7 is empty. So we just put 59 in the index 7. What about 32? 32 mod 13 is 6. Oh, yeah, 6 already have the value. Then you will do the linear. We will go to 7. 7 has already a value. Then we will check 8. Okay, 8 is empty. So we put the 32 in the index 8. 31 is 31 mod 13 is 5, but 5 already have values. What happened in this case? If you do with the linear probing, it will check 31 into the index 6. Index 6 already have values. Index 7 already has a value. Index 8 already have a value. Index 9 already have value. Then we will put the 31 into the index 10. Okay. And then the last one is 73. 73 mod 13 is 8. The same 8 in the index 8, there's a value. So you put 9. Yeah, 9 it has a value. 10 is also has a value. Then we put the 73 in the index 11. So this is the way to solve with the linear probing for the hash table. And the last one is the double hashing. I guess is better to see the process using this animation. Okay, so the same with the previous one, we have the HK, TK, and probes. Okay, so the HK means the first compression, and then TK is the second compression. So if there is a collision, then we have the double. Okay, we have the double hashing. We use the double function to indicate this one. So let's see how the system works for the double hashing. 18. Okay, 18 mod 13 is 5, and the TK, as we already know, the formula is 7 minus K mod 7. So K is the number, which is 18. Okay, so 7 minus 18 mod 7. 18 mod 7 is 4. So the result is 3. We have 5 and 3. Because 5 is still empty, just put 18 on the index 5. So the probe is 5. Okay. So you already know this table. Okay, this table is indicate the result. And what about the next? So we have 41. 41 mod 13 is 2, and the decay result is 1. Because 2 is empty, just put on the index 2. What about 22? 22 mod 13 is 9, and the decay equals to 6. 9 is empty, so just put in the index 9. 44 mod 13 is 5. Oh, 5 already have values. But what about the decay? The decay has also a value of 5. So how can we deal with this problem? In this case, because we have the decay of 5, so we can just use the formula this one, I plus j dk mod n. So I referring to the value that you have in the HK. So here I is 5, and then now let's have j equals to 1. So we have 5 plus 1 multiplied by decay. The result of decay is 5. Okay, so the result decay is 5, then 5 plus 5 mod 13. Then the result will be 10. So mod 13, n is 13 here, and we have the index 10. So the index 10 will be filled with the number 44. Okay. What about if we have 59? 59 mod 13 is 7. 7 is empty, so just put 59 in the index 7. What about 32? 32 mod 13 is 6, and yeah, we just have the index 6 with 32. Okay. 31. Oh, 31 has a result of HK, which is 5. But you know, 5 already has a value. And the decay, we have 4. So again, we will use the function here, I plus j dk mod n. So we have I equals to 5. Okay. So I equals to 5 and j equals to 1. So we will check 5 plus 1 multiplied by 4. So 5 plus 4, which is 9 mod 13. The result is 9. Ah, 9 already have values. Then you need to figure out another way. So we will add the j by 2. Okay, but if you check on the PPT, the j can be increased. J is integer. This is 1, 2, 3. If you cannot find any place to store that value, then you can increase the number. So j, let's suppose j equals to 2. Then we will have 5 plus 2 multiplied by 4. So 5 plus 2 multiplied by 4, it means 5 plus 8, then 13. 13 more 13 equals to 0. Then let's check. 0, aha, no value. So we will choose 0 to be the place for 31. And then the last one is 73. 73 mod 13 is 8. So 8, there is no, okay, there is no value of 8, then just put 73 on the index 8. So that's the mechanism for separate chaining, linear probing, and the double hashing. So hopefully it will help you to understand those concepts. Thank you very much for joining this video. See you on another video.